in the class section of the class here once we are finished. That way, if you miss a part of the recording or you're going through the homework or the assignments later on and there's something that you get a little bit stuck on and you want to go back and watch and figure it out, you can go back and watch us go through the notes together right in this section over here. So today, we are going to be getting into atoms, which are the tiny microscopic building blocks that make up all of the substances in the universe. So we're going to be kind of talking about two major pieces that go into atoms. The atomic structure, or how do you build an atom? What are the different parts of an atom? And then we're also going to look at the periodic table, which is a big chart of all of the 112, 113 atoms that scientists have discovered in the universe so far. And you can use the information on the periodic table to figure out some pretty interesting things about the structure of the different atoms. So these two things link together really nicely, which is why we're talking about both of them today. So this is the periodic table. If you've ever been in like a middle school or high school science classroom or a chemistry class of any kind, you've probably seen a version of it before. It's this big wide table that has all of these little boxes in it. These little boxes represent every single element, every single different atom that scientists have discovered so far in the universe. So you have some fairly common things like hydrogen, and let's see, oxygen is this guy over here. Carbon is pretty important for us right here. Aluminum, like the foil in your kitchen, as this guy right here, as well as some little bit less common ones, like zinc is this metal right here, and tin is down over here. The gases that go into like those signs that you see in stores at night, like neon or argon or xenon, those are all kind of over here. And then we also have things like that go into different types of nutrients, like potassium and sodium are over here. So all sorts of different types of elements that we'll talk about kind of as we go through some of the differences between them. And so today we're going to focus on the different parts of an atom. So what are kind of the different parts that make up an atom? And then we're going to talk about how can we use these little boxes on the periodic table to figure out some important information about the atom that they are representing. So here is a typical atom. Obviously, it's kind of a cartoon drawing of an atom structure. There aren't cameras that are small enough to take pictures of actual atoms, even under super duper powerful microscopes. But it is the smallest unit of matter, and it's split into kind of two sections. So we have sort of this outer section over here that has all these green rings swirling around it, and sort of this inner section right here that has all of these little particles that are all bunched up inside of there. So there are three main particles that we are going to be talking about today that go into making up each atom. There are protons, which are represented by these little red bubbles. Neutrons, which are with the protons in here. They're the little blue ones. And then electrons are the green guys that are swirling around the outside. So these rings that you see here don't actually exist. They're just showing that the electrons are constantly moving. So imagine that these electrons are like constantly orbiting around the atom. They're going round and round and round the outside of the atom. And then the protons and the neutrons are kind of hanging out here in the little middle section. So Where the protons and neutrons are hanging out down here gets its own special name. It is called the nucleus. So the nucleus is sort of this middle area of the atom. It's where the protons and the neutrons are hanging out with each other. So those are inside the nucleus, and then the electrons, these little green ones, they are outside of the nucleus. So the nucleus is kind of like the hard center, and then the electrons are zooming around the outside. So we've got our protons and our neutrons in the middle, and then the electrons swirling around the outside. So as we'll talk about a little bit later, this will come into play in a couple slides. The mass of an atom, or its weight, is pretty much the nucleus. The electrons are super duper tiny and light, so they don't really count towards the weight of the atom. It's pretty much all made up from these protons and neutrons here inside of the nucleus. So protons, neutrons together, electrons around the outside. But what are the differences between these three? What makes a proton different from a neutron, different from an electron? So like I mentioned, protons are part of the nucleus. They're kind of clumped in with the neutrons in this middle section. And the important thing to know about protons to start off with is that protons have a positive electric charge. So all of the different particles that we're going to talk about today, protons, neutrons, and electrons, have some sort of charge. Protons have a positive charge, like a plus charge. So it's pretty easy for me to remember because I just think that protons are positive. Both start with a P, so positive protons. Protons are positive. So one half of the nucleus are these little positively charged protons. The other part of the nucleus are the neutrons. So the neutrons, also in the nucleus, they have a neutral charge. So if the protons are like a positive, the neutrons are like a zero. They have no charge. They have a neutral charge. So neutrons are neutral. Sometimes people get confused because they see the N in neutrons and they think negative, which is what we're going to be talking about later. Don't think that. That's wrong. That's bad. Get that out of your head right now. Neutrons are not negative. They are neutral. So the first 5 letters here are all the same. Neutrons, neutral. So no neutral charge means like no charge or zero charge, essentially. So like I was saying earlier, the protons and the neutrons together, they're down in our little nucleus right here. And they make up the atomic mass. So like the weight of the atom pretty much all comes from the protons and neutrons. If you add them together, you get the weight of the whole atom. So even though atoms are incredibly super duper small and light, they still have a weight to them. And the more protons and neutrons that you have, the heavier your atom is going to be. So there are some atoms that are relatively light. They only have a couple protons and neutrons in the middle. And there are some atoms that are relatively heavy. They have hundreds of protons and neutrons all crammed together in the nucleus here. So the protons and neutrons together make up pretty much all of the atomic mass, or the weight. Neutrons, neutral, protons, positive. So we have positive charges and neutral charges all clustered up together in this little ball, making up the nucleus. So that's great for those first two guys, but what about our third ones? What about these little electrons out here? So the electrons are not part of the nucleus, like I've been saying. They are on the outside. They orbit around the nucleus. So they're constantly moving in these circles around the nucleus. The electrons are our negative particles. So protons are positive, neutrons are neutral, and electrons are negative. They have like a minus charge. I kind of like to think that electrons are where electricity comes from. And if you get hit with electricity, you're going to have a very negative time. You're going to have a bad, not so fun time. So electrons are negative. They're going to hurt you if you get a bunch of them hitting you at once. So they have like a negative or a minus charge. So protons are plus, electrons are minus, and neutrons are neutral. So they're like a 0 in terms of their electric charge. Again, only the protons and the neutrons count for the weight. Electrons are even super duper teeny tinier than protons and neutrons. So they basically don't really get counted. They just kind of do their thing and circle around the outside of the nucleus in their little orbits around here. So we've got our positive protons and our neutral neutrons coming together to make up the weight of the atom in the nucleus. Then our negative electrons are all swirling around the outside in their little orbits. So electrons are negative, protons positive, neutrons neutral. All right, any questions about any of those three particles so far?
Not for me, thank you.
All righty. So we've got our protons, neutrons, and electrons. We know that they're there, but the next thing that we want to know is how many of them are there. Now, the tricky thing about this is that each atom has a different amount of protons, neutrons, and electrons. So obviously, we're not going to try to remember all 100 and something atoms because that would be crazy. But luckily, we can get the information that we need in order to figure out those numbers from our little periodic table box. So on that big table that we saw at the beginning here, I mentioned that every single atom gets its own little box. So each of these boxes represents a different atom. This periodic table is kind of small and squished, so it only has the little symbol and the number. But on bigger ones or more full-sized ones, there are 4 different things that a periodic table box will tell us. The first 2 are pretty straightforward. We've got the name of the atom. In this case, krypton is the element that we're looking at, and the symbol for that atom. In the case of krypton, it is Kr, which makes sense, Kr for krypton. Most atoms, their symbol lines up really closely with their name. So like carbon is a C, oxygen is an O, neon is Ne, tin is Ti, zinc is Zn. But there are some atoms that are a little bit different, that have kind of a weird symbol, like potassium is K, sodium is Na, gold is Au. Essentially, it just has to do with like super old-timey names for the atoms that then got converted to English, but we kept their old symbols for the symbol. But regardless of what the symbol is, it's basically a really short way of writing out the atom so that we don't have to write krypton every single time. So the name and symbol, pretty straightforward. The other 2 pieces of information are these numbers right here. We have this smaller number at the top of the box and this larger number at the bottom of the box. The smaller number is called the atomic number, and the larger number is called the atomic mass or the atomic weight, depending on how different people say it. So we've got our atomic number and our atomic mass. The cool thing about these numbers is that every single atom has its own atomic number and atomic mass. And we can use these numbers to do a little bit of detective work and figure out how many protons, how many neutrons, and how many electrons do we have in each atom. So the first number up here that we're going to talk about, the atomic number, is really nice and straightforward. The atomic number simply tells us the number of protons in the nucleus of this atom. So if we want to figure out the number of protons, all you got to do is look at this atomic number. So krypton has an atomic number of 36, which means krypton has 36 protons in it. Each atom of krypton has 36 protons. So every single element, every single atom in the periodic table has a different atomic number and has a different number of protons. That's kind of how scientists initially organized the table and organized the atoms, was by how many protons do they have. If you have a different number, you are a different atom. So krypton is atomic number 36. It comes 36th in the periodic table, and it has 36 protons. So pretty easy peasy for our atomic number. The other number that is on our little box right here, instead of the atomic number, is the atomic mass, also sometimes referred to as the atomic weight. So the atomic weight is the approximate mass of one atom of an element. So how much does this particular atom weigh? Now, as you might guess, we cannot weigh atoms using like a scale at our house or by conventional measures of like grams or ounces or pounds. Because if you wanted to weigh an atom in the number of pounds, it would be something like 0.000000000000000000000000000000000000019 pounds. That is an incredibly small number, and nobody wants to write out like 19 zeros when they want to do the mass of an atom. So instead, scientists came up with a new measurement called an atomic mass unit, or an AMU. And they said, okay, we'll just say that a proton weighs 1 AMU and a neutron weighs 1 AMU. And then the weight of an atom is the protons and the neutrons together. So it'll just be that many AMUs. So this way they're able to kind of figure out the weight of an atom and use it to compare to other atoms. So krypton is kind of like a medium-sized atom. It has an atomic weight of 83. There are some atoms that are much smaller. They have atomic weights of like 3 or 4. And there are some atoms that are much bigger. They have atomic weights of over 200 in some cases. So the atomic weight tells us approximately how big is the nucleus of this atom. Now, while the atomic number directly tells us the number of protons that an atom has, unfortunately, the atomic weight on its own does not tell us about the number of protons or neutrons or anything like that. Luckily, we can still use the atomic weight in order to figure out our number of neutrons. And the way it works is something like this. We already said that the atomic number is the number of protons. And you may have heard me just mention that the atomic weight, the mass of an atom, is the protons and the neutrons together. So if we add up our number of protons and our number of neutrons, we will get the atomic weight. What that means is that if we have the atomic weight and we take away the number of protons, we'll be left with our number of neutrons. So, since the atomic number is how many protons we have, if we do the atomic weight minus the atomic number, we can calculate our number of neutrons. So our weight is the protons and neutrons together. The number is just the protons. So if we take the weight and we subtract the protons, then we will get the number of neutrons. Right? If we take the protons and neutrons and take away the protons, we have the number of neutrons. So this is how we can calculate how many neutrons are in an atom just based on the atomic weight and the atomic number. So remember, in the future, when you're going to be doing some neutron calculations, remember that you have to do a subtraction. Some people get confused and they think that you just do the atomic weight or that you do the weight plus the atomic number. Don't do that. Remember, neutrons, you have to do a little bit of basic subtraction in order to calculate it out. It's the atomic weight minus the atomic number. So, if we go back to our krypton example, the atomic number is 36, and the atomic weight, a lot of times you'll see on periodic tables, atomic weights will have big decimals after them. For this class, we're just going to round the atomic weights whenever we're calculating neutrons. So even though the precise atomic weight of krypton is 83.8, we'll say that it's about 84. So our atomic number is 36, and our atomic weight is 84. So we know that krypton has 36 protons, because that's the atomic number. And to figure out neutrons, we do weight minus the atomic number. So if we do our weight of 84 minus our atomic number of 36, we get 48 total neutrons. So if we take the weight and we take away the number of protons, we are left with the number of neutrons. So krypton has 48 neutrons and 36 protons together in its nucleus, and those guys combined together give us an atomic weight of about 84. All right, so again, the main thing to remember, and the thing that trips people up sometimes, is that the number of neutrons is not just the atomic weight. You have to do subtraction, the weight minus the atomic number. All right, I know that one was a little bit more involved than just looking at the atomic number for protons. So is anybody confused about calculating the neutrons? Anybody have any questions about figuring out how many neutrons there are?
No, sir.
All right, cool. Thanks, Ashley. So it doesn't really sound like it. So we've talked about our protons and we've talked about our neutrons. So the last thing that we have to figure out is electrons. How many electrons do we have in our different atoms? Luckily, this one is pretty simple once again. And the atoms that we're going to be dealing with in this class, they're called neutral atoms. And that means that they have equal protons and electrons. So in neutral atoms, the number of protons is the same as the number of electrons. No worries, Andrea. Thanks for coming by.
Thank you.
So, like I said, in our class, we're not going to worry about, there are different types of atoms called ions that have more electrons or less electrons. But we're not going to worry about those in this class. We're just going to focus on neutral atoms, which means that the number of protons and the number of electrons is going to be the same. So it's called the neutral atom because the positive charges from the protons are balanced by the negative charges of the electrons. So protons are positive, electrons are negative. So when they balance out with each other, we have a neutral overall charge. The positives and the negatives balance each other out. So with the atoms we're going to be dealing with, the electron number and the proton number is going to be the same. So for the simplest atom that is on the periodic table, it's called hydrogen. Hydrogen only has one proton. It has an atomic number of 1. It's the very first one on the table. So because hydrogen has 1 proton, that means hydrogen has to have 1 electron as well. So the positive and negative charges balance out with each other. Equal protons and electrons. So protons are the same, electrons are the same, and then the neutrons are just the atomic weight minus our protons. So to go back to the krypton example that we were looking at a little bit earlier, krypton has an atomic number of 36 and an atomic weight of 84. So we figured out our protons and our neutrons, but how many electrons are going to be in one krypton atom?
The
Same.
Yep, Sing is right, 36. And Sing, how did you know that there'd be 36 electrons?
Oh, I'm sorry. I thought you said Nassim.
Protons and electron is the same number, so same things.
Yep, exactly, Sing. Protons and electrons are going to be the same number. Krypton has an atomic number of 36, which means that krypton has 36 protons. So krypton also has to have 36 electrons. All right, awesome. Let's look at another one. So here is our periodic table box for carbon. Carbon has the symbol of C. Carbon is a pretty small early on element. It has an atomic number of 6 and an atomic weight of 12. So let's go ahead and work down the list. So first off, how many protons are in carbon?
6.
6.
Exactly. And Nassima, how did you know that there are 6 protons?
Because the atomic number is the same as the protons numbers.
Atomic number is 6, which means that we have to have 6 protons. What about electrons? How many electrons are in carbon?
6.
Ashley, you are correct. There are 6 electrons in carbon. And how do you know that it was 6, Ashley?
Because protons and electrons are the same.
Bingo. We just said that proton had 6 carbon. We just said that carbon had 6 protons, so it also has to have 6 electrons. All right, so finally, we'll see who's paying attention here. How many neutrons does carbon have?
6 right here.
And how did you know that carbon has 6 neutrons?
Maybe the weight or the mass minus atomic number.
Exactly. So the weight of carbon is 12.01. So we'll just say it's about 12. And the number is 6. So if you do 12 minus 6, you get 6. So carbon is one of a handful of elements that has the same protons, neutrons, and electrons. It has 6 protons and electrons because its atomic number is 6. And it has 6 neutrons because the weight is 12 and the number is 6. So 12 minus 6 is 6. Exactly. So that is how we can use the information from our little periodic table box right here to figure out how many of each type of particle are in every single atom if we wanted to. We could go through the list and for each one, figure out how many protons, how many neutrons, and how many electrons, all just based on the atomic number and the atomic mass. All right, great job, you guys. Does anybody have any more questions about protons, neutrons, electrons, either what they are or how we figured them out?
I'm fine, thank you.
All right, cool.
Will you be posting the video right after class so I can watch it since I missed it?
Yep.
Okay.
Yep, it'll be posted right after class. No worries.
Okay.
All right, so make sure that you feel pretty good with all of that because the assignment that you are going to work on today is basically exactly what we were just doing. So again, you can do the Google form or the Google Doc version, whichever one you prefer to work on. And you're going to be given a series of periodic table boxes of different elements. So we've got fluorine, scandium, platinum, radon, and, uranium, and borium. So for each of these atoms, I want you to tell me how many protons, how many neutrons, and how many electrons does each atom have. So if you do the Google form version, the one thing that you have to make sure to do is that there's only one little answer box area, not 3. So when you answer all 3 parts, you just have to physically write in, like say if this was your answer, you'd say 1 proton, 1 neutron, 1 electron. So you have to make sure to write in the number of protons, neutrons, and electrons for each atom. Again, to make things easier on yourself, I would highly recommend rounding the mass number down here. So for example, fluorine would have a mass of 19, and scandium would be 45, and platinum be 195, and so on and so forth. So again, you have your atomic number up at the top and the atomic weight at the bottom, which is all you need in order to figure out your number of protons, neutrons, and electrons. So that is what the Google form version looks like. So make sure if you do this version, you write in all 3 of your particle types. If you do the Google Doc version, it's a little bit different just because it already has the different types written out for you. So all that you have to do is fill in, I think it has 1 proton and 1 neutron and 1 electron. So it's the exact same group of elements, just laid out a little bit differently. Oops.
Mr. Michael,
Yes, Nasima.
can we do like another example? So like just more practice on weekend?
Yeah,
Please.
sure thing.
Thank you.
So here, let me pull up one that's not on there. Oh wait, actually, let me see if I still have it on here somewhere. I do. So I'll make sure to post this in the Google Classroom in a little bit. It's basically just a bigger, kind of more official version of the little one that's on the front of your. Ooh, hold on. All right. So let's take a look. I know that the numbers might be a little bit small for you. So let's take a look at magnesium over here. And I'll write down the information in the chat if you want to see it a little bit more clearly. So the atomic number of magnesium is 12, and the atomic mass is about 24. So how many protons are in magnesium?
You said how many protons?
Yeah, how many protons in magnesium?
It's 12.
Yep, exactly. And how did you know that it was 12?
It's 12. It's because the atomic number it's 12.
Precisely. So that is our protons. What about our neutrons? How many neutrons are in magnesium? We have a mass of 24 and the atomic number is 12. So how many neutrons are there?
Maybe 12.
12, exactly. Because for neutrons, remember, we do the mass, which is 24, minus the atomic number, which is 12. So in this case, 24 minus 12 is 12. So we have 12 neutrons. What about proton, neutron, electrons? We haven't done electrons yet. How many electrons are in magnesium?
Would it be 12?
12, exactly. Atomic number of 12 means that we have 12 protons and 12 electrons. Precisely.
So like the protons and the electrons is going to be always the same number.
Yep. In this class, it'll always be the same. Precisely.
Thank you, Mr. Michael. Thank you.
You are welcome. I'm trying to find a relatively another kind of quick and easy one to do. Oh, All right, let's do one more. Let's jump over to potassium over here. It's one of those weird ones where its name is potassium and its symbol is K. So potassium has an atomic number of 19 and a mass of about 39. So let's do it in the reverse order this time. So how many electrons are in potassium?
19.
19, exactly. The atomic number is 19. So that means that we're going to have 19 electrons. How many neutrons are in potassium?
20.
20, exactly. 39 is the mass. Oh, let's see. 39 is the mass, and 19 is the atomic number. So 39 minus 19 is 20. And then finally, hold on, so electron. How many protons does potassium have?
19.
19, exactly. Atomic number is 19, which means we have 19 protons and also 19 electrons. Precisely. So you guys are going to do great on that assignment. And actually, before I forget, let me go ahead and post this larger size periodic table in the Google Classroom in case you want to take a look at it later. All right, so that is essentially the homework for today, is for each one of these atoms to telling me how many protons, neutrons, and electrons are in it. And then for Wednesday, for tomorrow's homework, that'll be going up early tomorrow morning. It's a little bit simpler, just kind of a basic review of all the stuff that we've talked about today. So it has a little bit of information about protons, neutrons, and electrons. And then it gives you this helium periodic table box. Asks about the name, the symbol, the atomic number, the mass number, and then kind of leads you through, all right, if it's atomic number of 2, how many protons and electrons are in it? This one is a little bit tricky because a lot of people miss this because they just see protons and put down the proton answer, but there's actually a 2-part question on number 5. So make sure that you pay attention to the and put in protons and electrons for this one. And then number 6 is just asked about neutrons. So that's kind of a simpler little review session for tomorrow when we're not meeting in class. All right. Yep, Juanita, see you already. Thanks for the heads up though, appreciate it. All right. So does anybody have any final questions about today's homework, tomorrow's homework, or anything proton, neutron, electron related?
Not right now.
No.
All right. Cool. Let's see. So as always, if you do have questions, you can always send me an email, send me a text, leave a comment on the Google Classroom, and I will do my best to get back to you as soon